Till now, the concepts that we have discussed, they are about DC machines in general without any distinction between the generators and motors, except for small differences, right? Now we are going to discuss the DC generators in particular. Then we will discuss about DC motors as well. Now the first thing that you need to know about DC generators is how they are classified. This classification is based on how the field winding is excited. Excited is nothing but the current is given so that a flux is produced. So the first one is separately excited and the other is self-excited. Again, in self-excited, there is going to be further classification into shunt, series and compound. Further, in compound generators, there is going to be further classification into long shunt and short shunt. This is the main classification. Further also, the long shunt and short shunt, it can be either cumulatively connected or it can be differential connection. Similarly, short shunt also, it can be cumulative or differential. So we will consider these diagrams, these circuit diagrams one by one. First we will start with the separately excited one. So just like the name suggests, the field winding is going to be excited by means of an external DC source. Okay. So the generator or motor, we usually represent like this. Okay. So G, if you put, it is a generator. Now this is the armature windings. Okay. The field winding, we show it separately. So here we have the field winding. Okay. Now in separately excited, this is going to be excited by means of a separate DC source. That voltage is given by Vf and the current that is flowing in is called If, the field current, and the resistance associated with this field winding is Rf. Similarly, the resistance associated with the armature, that is taken as Ra. Okay. Now the voltage that is generated by the generator, we will take as Eg. Okay. And the current will be coming out of the generator because it is a generator. It will give out the current, it will supply current. And the voltage that is available at the terminal, this is Vt. This is different from the generated EMF. Okay. So we will see those relations as well, how these all variables are related with each other. First you can write the meaning of these notations. So this Vf is the voltage supplied to field winding and If is the field winding current, or you can simply say field current. What is Eg? This is the generated EMF. So these notations, they are very important. You are going to use them often, so it's better you make a good note of it. And Ia is the armature current, Rf is the field resistance of the field winding, and Ra is the armature winding resistance. And finally Vt, this is the terminal voltage. So what are the equations here? The field winding circuit, if you take, Vf is equal to the current If into Rf. This is one equation. And next, in the armature circuit, this is the field circuit and this is the armature circuit. Here you can see the generated EMF is Eg. There is a resistance Ra. So there will be a voltage drop across the armature conductors. And after that voltage drop is subtracted, then you will get the terminal voltage. So what will be Vt? This is equal to Eg minus the current through armature winding is Ia into Ra will give you the voltage drop across the armature conductors. So this is the second equation. So this is about the separately excited. Next we will see the self-excited generators. The first generator that we have is the shunt generator. Here the generator, the machine is going to be like this and the field winding is going to be in shunt. Okay, so that's why it is called a shunt generator. Now the generated EMF is Eg and resistance is Ra, armature resistance. Now the current that is flowing into the field winding is If, the same notation. This is RF, resistance RF. Now here the armature current will flow like this, and the final load current, even in separately excited, you can here write down IA is equal to IL here. Okay, so this is also one important parameter. This is the current that will flow through any of the equipment that we are connecting across the generator. Okay, so here you can see this is the load current because the equipment you're going to connect here. This entire thing is the machine now. So what are the relations here? If you apply KCL, then IA is equal to IL plus IF. In the separately excited case, IA was equal to IL. You can take it as the third equation. Okay, and this is the first equation. The next equation you can see the terminal voltage VT. What will this be? This is equal to EG minus IA RA, and this is also equal to IF RF. So this is the second equation. Next is the series machine. Here the field winding is going to be in series with the armature. So that's why it is called a series machine. Okay. Same as it is RAEG, and this resistance is RF. This current is IA, IL, and the field current is also IF. You can see that all of them, they are equal. So first equation you can write as IA is equal to IL is equal to IF. What about the terminal voltage VT? This you can write as VT is equal to E minus IA into RA plus RF. Okay, because RA and RF, they are in series. So this is the second equation. And finally the last one is the compound generator. So here there is going to be a series winding as well as a shunt winding. Okay. Now first, if you consider the long shunt. So here what is going to happen? Here you have the armature, the series winding you have. Now the shunt is connected in parallel to both the series winding and the armature. This is the long shunt. In short shunt, what is going to happen? The shunt winding is connected in parallel to the armature only. So this is the short shunt. In order to differentiate between the series and the shunt resistances, we take this as RSE and this is RSH. Similarly here as well, RSE and RSH. Okay. Now what about the currents? The armature current, as it is, it will be the current that is flowing in the armature conductors. Now this is the field current. This is going to be the load current. Similarly here there is going to be the armature current. Here it is going to be the field current, and here it is going to be the load current. So you can see that through the series winding in short shunt, the current that is flowing is the load current, whereas in long shunt in series winding the current that will flow is the armature current. What about the terminal voltage? This is the terminal voltage VT. Now if you write the equations for both of them, for the long shunt the current relation is IA is equal to IF plus IL. It is going to be the same in both of these. IA is equal to IF plus IL. The only difference is the current that is flowing through the series winding. Now what about the terminal voltage VT in long shunt? This is equal to EG. Here you can write EG and RA. Here also EG and RA. So EG minus IA times RA plus RSE. Right? And this is also equal to the voltage across the shunt winding IFRSH. Okay, so this is the second equation. What about in short shunt? Here VT is equal to EG minus IARA minus IL into RSE. Okay, so this is the second equation. You can write another equation. You can see that this is in parallel to this. So what will be the drop across the field winding? IF into RSH. This is equal to EG minus IARA. So this you can take as the third equation. Now next is cumulative and differential connection. So what does it mean by both of them? Now this field winding and shunt winding, the series winding and shunt winding, we have taken them, we have shown them separately when we are representing in terms of a diagram. But in the actual machine, what is going to happen? If this is the pole, then the series winding will also be wound onto it and the shunt winding will also be wound onto it. Okay. Now depending on the sense of these winding, the flux that is produced due to the series winding and shunt winding, they can either be additive in nature or they can be differential in nature, right? So you can see here, this is the pole, let us take, and the series winding we will take like this. So this current we will simply write as ISE to differentiate, and this is the shunt current ISH. Now if you can see the sense of winding, both of these windings, they will produce a flux which is in the upward direction, right? You can apply the right hand rule for that. So this is the flux direction which is phi SH plus phi SE. It is additive in nature. But if you take a winding something like this, the series winding we will leave as it is. This is ISE. Now the shunt winding, let us change the configuration. So now if current ISH is flowing like this, then this is the direction of the current. Here the current direction is this. Okay. So now if you take in the upward direction, the resultant, then phi SE minus phi SH. Okay. If you take in the downward direction, then it is going to become phi SH minus phi SE. So this is the cumulative connection and this is the differential. So you can see now that whether it is a long shunt or a short shunt, you can have either a cumulative or a differential in both the cases.